Hello, I'm Joe Cecil with the Soaring Eagle program at Oklahoma State University. My presentation's focus is going to be about some of our mentoring and outreach activities dealing with the theme of girls pursuing computer science or women in computing at the Matamo University or post university context. The Soaring Eagle program, is one of our successful K-12 mentoring programs. It's been going on for about 20 years. Its emphasis is on providing a very early and exciting encouragement to STEM for middle and high school students. We also have an elementary school emphasis within this program. Our uniqueness, in the Soaring Eagle is we use virtual reality and augmented reality based learning environments, what we call as VLEs, to introduce basic concepts in science and technology, and engineering and computer science. And the way we do this is we provide a very experiential experience, which means they can do hands on activities, they can interact with robots, they can explore the moon, they can walk through a virtual surgical simulation, for instance, wearing immersive headsets as well as haptic interfaces that give them the sense of touch. We also have a newer thrust where we are encouraging autistic students, including autistic female students, towards STEM. And this was an initiative funded by the state of Oklahoma. We are working with educational psychologists on encouraging them, towards STEM careers as well as programs by again designing very specialized learning environments. Another key aspect of a program is to emphasize role models. We've come to realize there are two aspects, to encouraging anyone towards a career goal. It's both the message and the messenger, and trying to understand, the values of a diverse group of students. So when we emphasize role models, we introduce them to surgeons. We have stories of successes as well as challenges to be overcome, not only by women surgeons but also by women engineers and scientists. We also emphasize, women of color and leaders in that community. We use examples like Katherine Johnson, the well-known NASA mathematician who was acknowledged very later by NASA for a contribution to our early space efforts. Then we also give the example of Mae Jemison, the well-known African American engineer and physician who was the first black female astronaut to go into space. Here is a view of one of our workshops. You see, one student is interacting with a Vive-based 3D environment using the headset and controller. Other students are looking at a 2D display, which is a non-immersive but group-based interactive system. You can see a couple of others who are more closer towards the screen, but you do see one of our mentors who are interacting with women, or rather with our female students in this initiative, which is part of a Women in Computing series of workshops. In whatever we do, we try to emphasize the care approach. Having a caring approach, obviously, is very important. And this is just a play on words to emphasize to everyone in our group that there are certain aspects, we have to reflect. We have to show our mentees that we care. We have to understand where they come from, and we sort of come up with this abbreviation. So where C stands for, communicate with your mentees with care. What is the goals of our program? What are their objectives in life? What are the career objectives? Then we try to make a correlation as well as, create meaningful experiences that can, validate their value system plus encourage them to look at new opportunities. We also, are big on applauding the mentees, every little achievement. We look at success as nothing but, very either it's a continuous or discontinuous set of baby steps, in progression, where the interest goes up along with the smaller achievements as they become more interested in computing as well as in STEM. R stands for, respect the aspirations, understand where they're coming from, where are they interested in going, and then providing opportunities that align the experiences with the aspirations. And the last one is the letter E, which is to encourage your mentees always and instill in them never to give up. Again, I'll go back to Mae Jemison's, well-known quote, where she said, never be limited by other people's limited imagination. So the sky is literally, where we want them to, or even to go beyond, or in terms of their limits. So when you look at the university level, we work informally with both the ACM, which is the Association of Computing Machinery, and other campus organizations, including IEEE and other student groups. And again, we encourage them to participate in outside the class informal projects, as well as if they have a class project, then we suggest, to pursue this in one of these areas related to virtual and augmented reality. Some of the projects they have worked on. So on the right side, you see a student, working with one of the 3D environments, and it can range from NASA projects. Our students compete in the well-known XAP competition annually, and recently we were selected, to work with NASA on designing user interfaces using mixed reality for the moon mission. We have more formal or well-structured summer programs funded by NSF where we introduce undergraduate students, towards research activities. They may be, working on surgical simulators. We work with a group of surgeons in Texas and Arizona, again virtually, or they might be working on robotic assembly planning research. Most recently, we have been fortunate to expose our students to create 3D based training environments to prepare our COVID 19 first responders. How do they interact with patients in a safe way? What are the precautions? How do you take nasal samples? As well as, hooking up patients to the ventilators. And here you see snapshots of some of our students. Here's another image of one of our mentees who herself, became a mentor to some of the K-12 women students in our program. You can only see the undergraduate student mentee. She's interacting with a haptic device and demonstrating a robotics interactive module to the other K-12 student who I had asked them to scoot to the other side. Maybe I should have found more space on the left side so that I could get a better view for this photo itself. Now, I'll give you three profiles of students, so that you'll get an idea of how we interact and encourage them, towards computing careers. First is a K-12 student from the ninth grade, others an undergraduate computer science major, and the last one is a graduate student. On the K-12 level, this is one of our ninth grade students. She's interested in STEM. She came to our lab with her mom. Even during the COVID, during this time period, we follow physical distancing. Obviously they can only come one at a time to the lab, but we have a fairly, safe program where they can come in at different times of the day with the parents, and then we wear masks and physical distancing rules are followed, and then we wipe and clean all the headsets, and so far no one has ever fallen sick. And then she is actually learning about robotics and sequencing since there's some interest in engineering and computer science. And this is part of a special program which I referred to earlier. We are working with autism therapists and educational psychologists, and we are exploring the role of something called applied behavioral analysis and introducing positive reinforcers, when some learning task becomes more challenging, how do we encourage students to continue that interaction, either taking a break, or we give them what are called positive tokens, of appreciation and encouragement. And that is still an ongoing activity for us. The second profile is of an undergraduate student. I just showed her, in the earlier slide. She is a sophomore right now. She was a transfer from a 2 year smaller college in the northern part of Oklahoma. And she came to us because after we publicized, so the way we do is we informally sent out, emails and open house workshops, or rather, in this case, virtual workshops during the COVID season. And then we tell people to contact us if they're interested. She was one of them, one of those who was interested, and we are working with her. We've exposed her to how do you create a virtual reality based environment, and she actually chose something interesting, to create a module where we could teach other students, on how to create these genetic algorithms. And she's been working predominantly on something called a crossover operator, which you can see, on the right side of the screen. So we also take surveys from the stakeholders, and I'll just give you a representative feedback from her. And she knows, I'm going to share this with the community. If you look at a point number one, we ask her for what are the main drivers and motivation to going towards computer science, and she says she likes the process of coding, which is not always the case. Many students come in because they like to create interfaces, based on human centric principles. Others like algorithms, and they focus more on design rather than coding. Her inspiration was her sister, who's a chemical engineer, and this is often the case in our program. We don't emphasize, early on at the K-12 level to go specifically towards CS. It's more all about, STEM. And then once they get to high school, we then work with them. And then once they come into college, we help them, decide on a program that they like. Of course, the takeaway again is, we ask them, how can we help them? What is the benefit of working on such interesting projects? And the student has replied that, being able to construct these practical applications means she has been able to expand her knowledge as well as skills about computer science. So here is a slightly different view of the simulation that the student has created. So it's a very slightly complex, I won't say very complex, part of the algorithm. And what she's been working on is in computer sciences, using genetic algorithms, you can take an assembly sequence and model it as a parent, right? It's a parent sequence, which is nothing but a chromosome of sorts. And then you can take another chromosome, which can represent a second parent, and then applying what is called a crossover operator, you can create a child sequence, right? So in computer science, if you do this repeatedly and you have something called an objective function, then you tell the algorithm to pick certain of the children, and then you repeat the process iteratively. There's a science and a body of knowledge that is based on human genetics. And so over a period of time, this could be 10,000 iterations or maybe 300,000 iterations, you will go towards a near optimal solution. So Isabel did something very interesting. She said, okay, I'm going to imagine there's a bee that has to travel to 10 different flowers, right? And we're going to try to minimize, the time taken by this bee to visit all these 10 places, right? And this is called the classical traveling salesman problem in computer science. And she's been adapting this approach for use in such an interesting context. The third student we want to talk about is a graduate student. She, as well as a couple of other students, have been working with NASA to create a payload movement or transfer simulation aboard the Gateway for NASA. For NASA, boots on the ground is 2024, and the Gateway, is going to be sort of a spinning structure similar to the space station but much smaller. But it's really important because the astronauts won't be going to the moon directly. It's going to be less manned than other, how should I say, space exploration context. We humans are going to fly to the spinning structure, and then it's going to be this gateway. Sorry, forgot its name for a second. The gateway, and then from the gateway, one or two astronauts will land on the ground. Given the fact, this mission is called the Artemis mission because it will have the first women landing on the moon. We are encouraging women to take a greater participatory role in this. And they worked well with the NASA engineers, outside the classroom. They had phone calls, then they presented the digital training markup at a conference, and they went on to publish the paper as well. Here is another view of another simulator, created by other students working with NASA, where they're helping an astronaut perform a repair task, with the help of what we call as service avatars that help the astronauts, perform different tasks. And this can be used as a basis to do, computer science oriented problem solving, such as, how do you do assembly planning? What's the most efficient way to do this? As well as, human centric computing, which is just to do, the quality of the interfaces, how do we interact with an interface? There are elements called affordance, for instance. There are elements, such as, cognitive load that will impact the astronauts. And some group of students, work on those elements as well. So, in conclusion, again, this is the last slide. I'll just recap the main points. Uh, so far, I've talked about the importance of encouraging women towards computing careers and computer science educational programs. We emphasize early encouragement in STEM and gradually refine it towards computer science for those interested. There are other women students who go on towards mechanical engineering or electrical engineering. We talked briefly about the mentoring at the undergraduate and graduate level. The last one, which I've not talked about so far, is as they progress towards graduation, we work with them in preparing for an IT or research career. We've talked about so far about opportunities to work on practical projects, and then we also work with them through mock interviews. We develop the interviewing skills. We work with them on the resumes. We are also big on encouraging them to network. My students typically, they go to conferences both within the US and outside. This year, of course, they had to do these virtually. We also introduce them to alumni to visit with the alumni, or when alumni come to the department or give virtual seminars. They also participate in campus interviews as well as in career fairs. So this is, in a nutshell, some of the activities that we do within our program here at OSU. If you have any questions, do email me. It's j.cecil at okstate.edu. Thank you.